Today we're going to be doing a little lesson on completing the square. Completing the square we've done a little bit just as far as when we did some type of a shape. We're going to get to that a little bit later in the lesson, so I don't want to give it away quite yet. But we have done just a tiny bit. I just kind of taught you the basics of it, but I just want to give you a formal lesson. You will use this next year in Algebra 2 when you get to the quadratic chapter. So, two different objectives for today. The first one is to solve quadratic equations by completing the square. And then the second is to relate completing the square to a topic that we've done actually in geometry this year. So you're supposed to have learned it in Algebra 1, and then we utilize it in geometry, and then you actually officially learn it next year. Let me catch the phone real quick. Mrs. Root? Check it out. Have a great weekend. Okay, so let's just review factoring real quick. So that we factor whenever we do quadratics. We have x squared plus 6x plus 9. So we want to think of two numbers that we multiply to give us 9 and then add together to give us 6. So what two numbers are those?
3 and 3.
Yeah, 3 and 3. Okay, so we're going to write x plus 3 times x plus 3. Alright, so why don't you guys try the second one there, x squared minus 4x plus 4. Let's just think about that one for a second. So can you factor this one? So two numbers that multiply to give you 4 and add to give you a negative 4. What are they? Riley?
Negative 2.
Good, negative 2. Okay, so we have a negative 2 and a negative 2, and we know that the variable is going to be x. So x minus 2 times x minus 2. Now let me ask you this question. If I didn't want to see two factors here, how could you write it as one factor? Squared. Good. So x plus 3 squared and x minus 2 squared. Okay, so a perfect square trinomial is what these two examples are. And it's always going to factor into the same way as we've been doing here. And notice just real quick here, what is A, or what is our leading coefficient here? What number is it? So our leading coefficient is the one that's right up front here.
One.
Good, it's going to be 1. So to complete the square, you always need a leading coefficient of 1. Okay, so the process of completing a square, you have a quadratic that's x squared plus bx plus b divided by 2 squared. So it will factor into an x plus b divided by 2 squared. So you kind of look at that and say, well, what exactly does that mean? So let's look at this example here. We have x squared plus 8x plus 16. So what we want to do to complete the square is take this number, and does anybody remember from what we did already this year? And take this number and divide by 2. Okay, so b is 8. We're going to divide by 2, okay, and that's going to give us a 16. So what is half of 8? 4. And then if we square that, we get 16. So we know a perfect square trinomial is going to be this b divided by 2. So 8 divided by 2 is going to give us that 4 that we're going to put in that blank there. Okay, so to complete the square, the process is you have the variable b, or not the variable, the coefficient b. Okay, and then you're going to square that to get your c value. Now, let's just go on to example 1 here. We want to find c to create a perfect square trinomial. So we're not completing the square, we aren't factoring, we're just figuring out what that value of c should be. So we're going to look at b, which is 14. Okay, remember is what we do first.
Divide by 2.
Good, divide by 2, which is
7.
and then what do we do to get c? Square, which would be 49. Okay, you guys do b on your own. See if you can figure this one out. It's not an even number, so it's not quite as easy as A. But you guys can do it. Okay, so we're going to take half of 5. It's easier to see this in fraction form than it would be in decimal form. So if we take half of 5, that's 5 halves. Then what are we supposed to do with that? Square it. But when we square it, we have to remember to square the top and the bottom. So C in this case is going to be 25 over 4. Good. Okay, so the main topic for the day, solving by completing the square. You always have to remember here that A must always equal 1. If it's not 1, then you want to try and divide through by that number to get it equal to 1. So we want to complete the square in times that we can't factor. So if you were to try to factor these, so for example, this one right here, x squared plus 10x minus 3 equals 0. You're not going to be able to find 2 factors of 3 that are going to add or subtract to give you that negative or that positive 10. So this is when we want to complete the square. So I'll do the first one with you, and then I'll let you try B on your own, and then we'll go on to the next slide. So we have x squared plus 10x. Now, the first thing that I want to do is move any constant I have to the other side, because I want to just concentrate on finding C. Okay, so that blank there, I want to make that perfect square trinomial. So what are we going to do with this 3 to get it to the other side? Good, we're going to add it. K is equal to 3 plus whatever we fill in here. Remember, equations have to balance. It's like a scale. So we have to put that on the other side as well. Now, what am I going to fill the blank in with? Right here.
25.
Is it going to be 5 or 25?
25.
Good, because half of 10 is 5, but remember we have to square that. So we're going to put 25 here and 25 here. Okay, we can do the right-hand side pretty quick. That's going to be equal to 28. Now, we want to factor this, okay? But that last slide when I told you it's always going to factor into the factor squared. So we can kind of just think, okay, well, I know that I'm going to have this, and we know why, because we know 2 numbers are going to multiply to give this number and add to give this one. So what number is that? Good, it's going to be x plus 5. Okay. This would be the same thing as x plus 5 times x plus 5, but we want to write it this way because we're solving. Okay. Now, in order to solve for x, I need to get that x by itself solved for completely. So what are you going to do to undo that square?
Square root.
Good, take the square root. Okay, so we have x plus 5 is equal to the square root of 28. And something that you guys probably haven't learned quite yet in Algebra 1 or geometry this year is that when you put a square root in the problem, you have to remember plus and minus. So that you will get to next year with Algebra 2. Remember, this is just kind of a bonus lesson for this year. So we're going to add in the plus and minus. So maybe when we get there next year, you'll actually remember that I said that briefly. Okay, one more step to solve for x, and that's to do what? Subtract 5, good. So your final answer here is x is equal to negative 5 plus or minus the square root of 28. Now, we can simplify the square root of 28, but for the basis of this lesson, let's just leave it like that because we're just trying to complete the square this time. All right, write this next one down. X squared minus 16x plus 76 is equal to 0. So follow this one right here. I want to see your plus blanks. So you're going to complete the square and then solve. I'll give you a few minutes to do that. actually solve. So get to the point where you're gonna factor and then solve for x. So you'll have to take the square root, it'll be the same process there. Then if you want to compare with your neighbors at your table, just make sure you guys got the same answer. Or in the case in the back, you can just share with each other there. Okay, Ian, what did you fill in the blank with?
Fill it in with 64.
Good, so we took half of 16, which was 8, and so we're going to fill in with 64 and 64. Okay, so somebody tell me what this one was factored into. So Tanner, do you have that answer, what it was factored into?
Not yet.
Not yet, you're working on it? Okay. Aaron?
X plus 8.
Okay, so I'm going to write x and 8 here. There's actually one thing that's a little bit different in this case. Is it going to be plus? No, it's actually going to be minus because we have to get this negative 16. So I kind of tricked you with that one. I didn't really tell you that that would happen. So really whatever this second sign is, you have to pay attention to. So whatever this sign is going to be what you fill in the blank with because you have to get that positive 64 in the end in this negative 16. Two negatives added together will keep it negative. Okay, so that's going to equal negative 76 plus 64. What did you guys get there? Yeah. Negative 12. Okay. Now what are we going to do? You're going to take the square root. X minus 8 is equal to plus or minus the square root of negative 12. Now, can we take the square root of a negative number?
No.
Okay, so some foreshadowing into next year as well. This actually means it's an imaginary number. That's okay, we're not going to get quite that far today in this lesson. One more step to solve for x. Good, add 8. So x is going to equal 8 plus or minus the square root of negative 12. Does anybody know what that negative would come outside of the radical as? I'm just curious if anybody knows.
Very small number.
A very small number.
Pi? Am I close?
Say it again.
Was I right? Was it pi?
Not pi. It sounds a lot like pi.
Pi?
Pi, is that what you said?
Yeah.
Yeah, the imaginary number. So you guys are really good because the square root of negative 1 is actually equal to the imaginary number I. There's no such, I mean,
I have a friend who taught me that.
it's not a real number, so we can't physically see it like we can all the other numbers. And you're going to realize that when you start getting to the graphs of quadratics. So if you really want to get to the final answer of this one here, x is going to equal 8 plus or minus. This square root of negative 1, we're going to write I, and then the square root of 12. And again, you could simplify the square root of 12, but we're going to keep it pretty basic for right now. Okay, do you guys have any questions on either of these two examples?
And then Helen had negative or had positive 8. I'm like, maybe she was correct. So then I changed my answer to positive 8. And then you're like, yeah, it's going to be negative 8. I'm like, but I had it.
There's a lot of factoring on.
Yeah.
You cheated is what it, like half, over half of you.
Okay, so we're going to do one of these. We'll do this one right here, solve. We're going to do the same way. So what if A does not equal 1? We'll make A equal 1 by dividing. Okay, again, we're not going to do this one. We're just going to look at this one right here. So 2x squared minus 12x is equal to negative 14.
Two, like you divide everything by 2.
Yeah, we want to divide everything by 2 because we want to get A, which is right here, which is 2 right now, equal to 1. So if we do that, we end up getting x squared minus 6x. And in the same step, because our number's already on the other side, let's just go ahead and put the blanks in. So we have plus blank is equal to negative 14 plus the same thing. All right, you guys tell me, what are we going to fill in the blank with?
Wait,
36.
Mr.
Yes.
Wouldn't you divide both sides of this?
Oh, sorry, yes. Thanks for catching that. Just making sure you're paying attention. Okay, negative 7. There we go. Okay, so good catch. Now, you guys just said we take half of 6, which is 3, square it to get 9.
36 times 12.
Okay, what does this side factor into? Negative 3, and x up front, so x minus 3, what do I need to remember up here? Squared is equal to 2. Good. Okay, you guys finish it out real quick.
There you go.
Alright, check your answer. How many got it? Good, pretty much everybody. Alright, so how does completing a square relate to what we have learned in geometry this year? Does anybody remember? Is it coming back to you? No? Circles. Okay, how did it relate to circles? What?
Well, it's a shape.
We completed the square to find something of the circle. Do you remember what that was?
Circumference.
Not the circumference. We could find the center by completing the square, but what was that big old long
Diameter.
chord? You guys are saying
Diameter.
So how about the equation? Okay, so the circle formula, the circle equation, okay, which if you remember was x minus h squared plus y minus k squared is equal to r squared. So I put bonus points for remembering what this is derived from. Do you remember what the circle equation was derived from?
Pythagorean theorem.
Pythagorean theorem, good. And then there was also something else that went off of Pythagorean theorem. Good, distance formula, and then we went from both of those to the circle formula. So good memory. Okay, so let's do one of these. We'll look at A. It's complete the square to find the equation for a circle with the general form of the equation given. So it reads x squared plus 6x plus y squared plus 5 equals 0. Now these are actually set equal to 0, and instead of just completing the square one time, we have two variables, so we have to do it 2 times. Now, the first thing you want to do is move any numbers that are just by themselves to the other side. So is there anything that we can move to the other side? 5. Good. Okay, so we have x squared plus 6x. And while we're writing it, let's just go ahead and understand we're going to have to complete the square here because there's no number after that that goes with the 6x. So plus blank. Plus, we still have y squared on the left-hand side.
We had a blank after that too.
What was that question?
We had a blank after that one too, or is it?
Well, do we have to?
No, I don't think so, right?
We don't have to because there's no bx term for completing the square. So we're just going to put plus y squared equals, we're moving that 5, negative 5 plus blank. Since we filled a blank in here, we're going to put that there as well. Okay, what goes in the blank? We kind of just did one that was like this. Good, 9. And 9. Okay, so the x squared plus 6x plus 9, what's that going to factor as?
X plus 3.
X plus 3 squared plus y squared, because we don't have to complete the square for that one, equals 4. Good. Okay, now this is just a little bit of review for your circles. What is the center of that circle?
Oh, it's
3.
So we want to look at our numbers here.
3, 1.
negative 3.
Negative 3.
Okay, I'm hearing 3 and 0. Is it 3, 0 or negative 3, 0?
It's 3, 0.
One of those two.
3, 0. It's 3,
One of those two. So we always want to take the opposite. Remember, it's x minus h. So if this is positive, that means there's a negative in there somewhere. So it's going to be a negative 3. Since there's no number here, it's going to be 0. One last question, and then we'll finish the lesson. What is the radius in this example? 2. Good.
Oh, okay.
Okay, and that's just coming straight from what we learned with circles this year. Okay, do you guys have any questions on completing the square?
No.
No. Okay. Is that easy?
Oh, thanks.
I will ace. All right, so a little teaser for Algebra 2 next year. I think you're gonna do pretty well remembering it. Hopefully you've done it quite a few times this year already. So, you guys aren't gonna have any homework over this, but we might do something else. All right, have a great weekend. I will.
Stop taking on me, weirdo!
That was really.